So hi, I'm Michael Dawson, and today I'm going to talk to you about keeping the Node.js infrastructure community humming. A little bit about myself before I get started. I'm Michael Dawson. I'm the tech lead for the team within the IBM Runtime Technologies group that builds Node.js for consumption and use in our products. We have about 53 products that incorporate it, as well as for delivery to our customers and things like our Bluemux cloud platform. Now, our development model is very much community focused, so our goal is to do most of our development out in the community and then pull that back in for internal use. And because of that, we're active in the community. I'm a Node.js collaborator and CTC member, and very active in a number of the work groups like the API work group, the build work group, the benchmarking work group, and so forth. And that's why I'm here today talking to you about the build work group. So I'm just the one that gets to be here and have the privilege to talk to you about all the great work that the build work group is doing. But there's a great group of people working on this and keeping the infrastructure running. In particular, I'd like to call out Joanne Bergstrom. If you've ever been involved in trying to get something up and running in the infrastructure, you'll probably run into him because he really carries a large portion of the load in making sure that things get done and that the infrastructure overall keeps on working as it should. As well as Rod Vag, who also has made quite a big contribution, particularly around things like the Raspberry Pis that you'll see later on in the talk. But overall, it's just great to have such a good group of people working together. As always, though, if you're interested in this area and you want to get more involved, we always need more people to help out, and we look forward to having you join us. So just to start out, what's the purpose of the build work group? So the core purpose is to provide the computing infrastructure that we need to keep all the things running. So things like our builds, our website, and so forth. We also focus on streamlining our builds and tests because we want to make sure we can get those through quickly enough and efficiently enough that it doesn't slow down the overall contribution process. And so specifically, we end up doing things like maintaining the Jenkins infrastructure, the benchmarking graphs and generation that we've seen earlier today, the website like nodejs.org, and much, much more, which I'll talk a bit about as we go through the presentation. One thing that's a little bit unique is that our approach is very much donation focused. We don't necessarily want to go out and buy all the infrastructure that we want. We want to find people who can contribute that, so companies or individuals who can help contribute the infrastructure that we need, because that's really in line with Node's philosophy of contribution-driven development. And where we can find people that are interested to contribute the infrastructure probably also means that we have active people who can get involved in Node. And so by using that approach, we get and encourage more involvement in the Node community itself, which is what we want. Most of the infrastructure is cloud-based, and it's spread across one or more providers so that we actually have some redundancy and so forth. In terms of our infrastructure providers, we have Tier 1 and Tier 2 providers. The only real distinction is that the Tier 1 providers provide a larger portion of the overall infrastructure that's needed. So I would like to say thanks to our providers here, DigitalOcean, Rackspace, Microsoft, Joyent, IBM, through the Open Software Lab at the Oregon State University, as well as SoftLayer, Voxer, Scaleway, NodeSource, Cloudflare, and ARM. Without those providers, we really wouldn't be able to have the infrastructure and get all the builds that we do manage to get through today and efficiently as we do today. In addition to sort of corporate participants and donors, we also are really trying to encourage community donations as well. And a good example is, in terms of our ARM testing, we needed quite a few ARM machines, and we wanted to cover the different architectures like ARM 6, 7, and 8. So at one point, we just really didn't have enough. It's harder to get the test to run quickly on ARM. So we didn't have enough. We made a community call out and said, anybody who could donate hardware resources, that'd be really great. We had a really good response, and you can go and see a number of the donators. There's even more now. The nice thing is if you do give some hardware, it'll usually end up showing up with your name. So if you can go into the CI, and I just hope the one that I donated isn't always down and people curse it or anything like that. But this is a nice picture from Rod Vag that shows part of our Raspberry Pi cluster. So we have quite a few of them, and they're, again, all through the community donations that is what made this possible. Diving down into the infrastructure itself, so we use Jenkins as our continuous integration system. We have two separate environments. We have basically a build test environment and then our release CI. And we have those separated out so that you can, restrict the number of people who have access to the release CI and machines, so we can have really good confidence that, we know the configurations are as we expect. Only the software that we want to have running is running on those machines, and have good trust in the binaries that we build and then ship from there. In terms of the build infrastructure, we have about 116 machines at last count, a whole bunch of different architectures, x86, 32, and 64-bit, ARM, various flavors, PowerPC, Big Endian, Little Endian, as well as S390X, and a bunch of operating systems like Linux, Windows, AIX, Mac, OS X, and FreeBSD, so quite a good variety. The release infrastructure is a little bit smaller. It's about 14 machines when I took count. Still has a wide diversity of architectures, as well as a slightly smaller set of operating systems, but as we bring on support for more and more operating systems, we should see that expand to pretty much the same set that we have in our build infrastructure. I only showed Linux as kind of one line in the previous page, but I wanted to show this because really we do test on a variety of Linuxes. So we get more test and build across distributions like Ubuntu, Fedora. And so you can see that, even though I say Linux, there's a lot of different flavors, both to test different variants of the operating system and distributions, but also so that we can test the different architectures like Power, ARM, x86, and so forth. Digging down a little bit into the builds themselves. So this, if you go to the CI, and everybody can go and take a look at the CI jobs, this is the first page that you'll be presented. Most times, builds start out with the node test pull request. So somebody says, hey, I have a pull request. I want to test before that gets committed. It's basically a rule that needs to be tested. So somebody kicks off the node test pull request job, which is the one down here at the bottom. It then kicks off the one that's higher up, which is the node test commit. And then node test commit farms it, sort of fans it out across all the different platforms. So if you have a pull request, it's going to be tested across all those different architectures, across all those different operating systems when you launch your build, which is a good thing. In terms of the job, so now looking, delving into the job, the node test commit, and there's generally one that's specific to each of the platforms, but this is an example. There's not a lot that's really interesting in the job itself. We use Jenkins, but we don't necessarily have a lot of the logic built into the Jenkins job. Instead, it is built into the Makefile. It's a good thing. This is a picture of what you see if you actually open up the job. It's a bash-like syntax, so if you're familiar with writing bash shell scripts, you'll feel fairly at home. But really, it just sets up some environment variables and then calls the build CI target to actually start off the whole process. The good thing is that although most people don't have access to go and look in at the jobs themselves, everybody has access to the Makefiles, which are in GitHub. And if you're interested, check that file out, the Makefile out, and you can look at all the different jobs, their dependencies, and all that kind of stuff. So you can easily delve into the details of exactly what makes up those build jobs. Looking at the machines that are used when you launch those builds, so most of them are virtual. There are a few key exceptions. So the first one is ARM. It's not easy to go out and get ARM virtual machines. So through the donations in the community, we've managed to build quite a big Raspberry Pi cluster. You can see the groupings there. Again, a nice picture that Rod sent me. And so ARM is physical machines located at node source that we use to build. The other exception is our benchmarking machine. So we have a machine from SoftLayer. That's in SoftLayer, you can actually get physical machines, and you're the only one using it. And we use that for benchmarking so that when we have benchmarking runs on different days, we can actually compare the results because we know that nothing else is running on that machine, the machine hasn't changed, and we get comparable results. So that's important. So that's the other area. Other than that, it's pretty much virtual machines, basically distributed across the world. I gave you the list of tier 1, tier 2 providers, and so those 150 machines or so are pretty much spread out across all those different providers. The thing you'll start to realize is That is a lot of machines. How do we possibly manage all those machines? They're also cloud machines, which there's not really any guarantee that a machine you've provisioned today is going to be there tomorrow. You know, most of the time they stick around, but the providers don't guarantee that, and so you may be faced with having to re-provision those machines at a pretty regular basis. Our answer to that is Ansible, and I'll tell you about that because it's quite a neat tool, and it's something that, you know, really helps us in the build group manage all those machines. First nice thing about Ansible is it's agentless. You don't have to go and install anything on the machines themselves. It connects over SSH and does all the work that it needs to do just by using SSH itself. There's 3 key files: the Ansible inventory, the Ansible playbook, and the Ansible vars. And I'll delve into each of those individual files as we look at it. The other thing I did want to point out, though, that if you really want to get into the details of Ansible, because I won't be able to go over all of that, again, it's available in the build repo. So if you go to node.js/build, you can actually look at the files. At the top level that's where you'll find the Ansible inventory, which is the files of all the machines we have configured. And then at that same level, there's a number of directories, one for sort of each OS architecture combination where we need to do different things. And within those directories, you'll then find the playbook and the vars that go in them. Looking at the files themselves, the playbook is basically just a list of the machines that you can configure. It starts out, you know, if you look at the part that has the first line in brackets, that's just a particular type. So like, you know, maybe it's Ubuntu 14, and then underneath it is a list of machines. Most often when I'm actually adding a new machine, what I'll end up doing is commenting out the other ones so that, you know, if I run Ansible, it'll actually configure all the machines for the particular category that you're doing the configuration for. And while Ansible is actually set up so that if you run it on something that's already configured, it leaves it in the exact same state, I prefer to just modify the ones that I'm actually modifying. The other file is Ansible vars, and really that's just a place where we put the variables that you don't want to have hard-coded into the playbook. The playbook is your list of steps that you're going to have to configure the particular machine, and something like the list of packages you need to install, you don't necessarily want to have that hard-coded into that overall set of instructions. You just want to pull that out and say, you know, here's my list of modules, and if I need to add an extra module, I can easily locate the section to be able to add that in. So that's where Ansible vars comes in. It's sort of your configurable pieces. And I know this is hard to read, but it's basically a list of steps. So Ansible will go through and say, okay, I'm going to start out by first updating you to the latest. So if you're on Ubuntu, it'll say, let's do an apt-get update. And if you're at 14, it'll leave you at 14, but let's apply all the patches for that particular level. It then says, okay, let's do things like, well, I'm going to need a particular user. I'm going to have to install, we use a user called IOJS, so let's create that user on the machine. It'll go through installing all the packages. It does things like pulling over the Jenkins jar. Jenkins is a Java application, so we need a jar file, which will run the agent that connects to the overall infrastructure. So it installs that jar file, installs a startup script so that, you know, when your machine reboots, it starts the Jenkins agent. So Ansible very nicely goes through and runs all these steps, and generally it knows about the different ways to do that on different platforms. So for example, on Ubuntu, it knows maybe you use apt-get, and on Red Hat, you use Yum, and so you've got your list of packages, and it can go through and do all those things for it. So it's a really great tool to say, I'm starting with a bare machine, point Ansible at it, and, you know, some amount of time later, 10, 20 minutes, you end up with a machine which is fully configured and can connect into the framework. And really, it saved me a lot of time. On the PowerPC side, we had to move from, you know, our initial set of machines to sort of a new test infrastructure they wanted to validate, to the final production system that, you know, where our new machines are going to come out of. So I've had to, you know, configure another 5 machines in, you know, less than a couple weeks. So it's something that's made that relatively painless versus actually having to go on and actually manage each of the machines themselves. So that's how we manage to deal with all large number of machines. The next thing is we definitely have to be nimble because we have to make sure that we can get through the builds quickly. It seems like in the community, the tolerance level is maybe around 30 minutes. So if we keep it under that, we can actually make sure that everything gets tested across all the platforms for every pull request. If we start to span it further than that, it's going to be hard to keep that up. So it's important that we can do things quickly enough to actually meet that. couple things that we do. We make sure that we have multiple machines, so at least 2 machines for each of the platforms that's going to be tested. Because often, there's more than one build going on, and that lets us make sure that, you're not constantly waiting if there's multiple things that are trying to happen at the same time. The next one is Ccache. That's a tool that basically says, if I've already compiled it, let's not compile it again. Because when you look at the build jobs, a good portion of your time is spent actually doing the compilation. And if you can basically figure out, I haven't changed very much, you can really cut that down. So I think that shaves off 10, maybe 15 minutes from some of the platforms. So Ccache is an important tool. There are some platforms where we just can't cut it down to be fast enough. So things like ARM, we just can't get the full set of ARM tests to run fast enough to sort of fit in that envelope. In that case, we use what are called fan jobs, where we basically split out the jobs and run a portion of the tests on basically a different machine in parallel, and at the end bring all the results back to get your results. So that's another key technique that we use, I think, mostly for ARM and Windows today, to be able to get all the tests executed in time. And then finally, not just when we're running in the infrastructure, but also when people are running it on their desktop, we want to make sure that we can run as fast as possible and take advantage of all the hardware that's there. So the communities work really hard to basically separate the tests out into tests that can be run in parallel versus those that have to be run sequentially because they use resources you can't share. And so definitely in the jobs, in the CI jobs, we take as much advantage as we can, setting the parallelism to match how many CPUs we are to get through those tests. And put all together, it lets us get through well under that 30 minutes, which is a great thing. Another interesting thing we have to deal with in the build work group is trust delegation. We have a bunch of different environments, and we want to give different people, collaborators, people who are on the build group, access to the various pieces of the infrastructure. But it's also very important that we make sure that we sort of limit who can access that, because we want to have confidence that the infrastructure is going to continue to operate as we expect. And so we have this concept of trust delegation. We have 3 different levels: infra, test, and release. And we manage keys. So there's keys that will give you, SSH keys that will give you access to those particular sets of machines. And then we use GPG along with a GitHub repo where we have the key stored to be able to easily give people access to the right areas and basically give them the access to the trust that they need. So I don't want to leave you with the feeling that it's only about builds and generating those binaries, which is important, but the build group also does other things. So we maintain the website, obviously very important. The place people go to get information, downloads, all that kind of stuff. The benchmarking website, so maintaining the jobs that run the benchmarks, publishing it to the website, benchmarking.nodejs.org. We have tools like machine notifications. Again, we got a lot of machines. If something goes down, we need tools to help notify people so we can go fix that. We have a team looking at build bots. Those are bots in GitHub to help us automate routine tasks so that, hopefully we can be more efficient. If a PR is opened and it's got test in the title, automatically adds a test tag, and basically tools to sort of make our lives easier and take the routine actions so that we don't need to do them ourselves. We have tools to provide rsync mirrors so that people can get downloads through rsync, as well as, we're even thinking of supporting other projects. We have quite a nice infrastructure across a lot of platforms, and we're figuring out, how might we support other projects like Node Serial Port, where it's important to the ecosystem to have support across all those different platforms as well. In terms of machine access, we understand that not everybody has access to all the different operating systems and platforms that we support. So there is a process for giving people access to those machines. So you've just submitted your PR, one of the collaborators runs the test jobs, and you find it passes on everything except for Windows, but you don't have any Windows machines, or you're running on Mac, you don't have any Linux machines. There is a potential way to get you access to some of the build machines so you can investigate and help fix that as well. So if you want to go, you can go. I've got the link there. You can go read up on the process for making that happen. In terms of current challenges, OS X is always a bit of not always, but is a bit of a challenge for us in that, sort of 2 ways. It's harder to find a provider who provides OS X virtual machines. So we're still working that through. That's the one area, we don't have a provider or enough providers to have good coverage. The other thing is that OS X Apple doesn't make it easy to find older versions. We still support, I think, back to 10.8. And so actually getting versions of the OS from 10.8 forward is not very easy. So even if somebody gave us hardware, it would actually be difficult to continue to do that. So that's one area we're still working through to come up with something that we're really happy with. The other one is Jenkins. Jenkins is a large Java application. Our community is really JavaScript focused. So we don't have as many people as we'd like necessarily who are really interested in working with a Java application and configuring Jenkins, making everything work well. So it works well for us, but that's one area where we sometimes have a little bit of friction. So just before I close out, I want to make the call to say get involved. I think the Build Workgroup is a great place to learn about some things you wouldn't necessarily be able to do otherwise. If you want to, at some point in the future, build your own infrastructure to support a good-sized project, business, or whatever, it's going to give you the opportunity to learn about a lot of interesting things like the hardware, the operating systems, Ansible as a tool, how do you configure your machines. Even things like OpenStack, which is what's often used to configure a lot of the virtual machines in those providers that we have. If you don't want to get involved in time, you can also consider just donations. Make a small donation. If you already have a Raspberry Pi that you bought and it's in your basement, never use it, you can actually ship it to Rod Vag. He'll add it to that nice Pi cluster that we saw before. If you do want to get involved, most of the work is done through GitHub, so you can go through, look at the issues, see what's going on, and there's also an IRC channel that you can join and sort of participate if you want as well. So that's everything that I wanted to tell you today, and I think I'm just about on time. So thank you very much for listening.